Okay, Wildcats, today we're looking at Thursday, March 28th, application of exponential functions on page 65. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at our notes. Application of exponential functions on page 65. X equals time, Y is the final amount, A is equal to the initial amount, R is equal to the rate converted to a decimal, N is the number of times compounded. Now, with the variables defined, we have exponential growth. Y equals A parentheses 1 plus R to the X power. Exponential decay is Y equals A parentheses 1 minus R to the X power. Compound interest. Y equals A parentheses 1 plus R divided by N raised to the N times X power. And then compounded continuously is Y equals A times E to the R to the X power, or R times X. All right, so if you would, update your notes. All right, now your notes are updated. Let's take a look at our examples. Set up and solve each of the following problems. If you deposit $5,000 into a savings account paying 1% annual interest, how much will be in the account after 30 years? So this is compound interest, so our equation is Y equals A parentheses 1 plus R divided by N raised to the nx power, where A is 5,000, N equals 1, R is 0.01, and X is 30. Okay, now we're going to substitute these values into the equation. So Y equals 5,000, parentheses 1 plus 0.01 divided by 1 raised to the 1 times 30. And that equals $6,739.24. So the amount in the account after 30 years will be $6,739.24. All right, if you would, go ahead and finish up example 1. All right, let's take a look at example 2. Mr. Flowers will purchase a rare 1959 Gibson Les Paul. I'm sorry. Mr. Flowers purchased a rare 1959 Gibson Les Paul guitar in 2000 for $12,000. Experts estimate that its value will increase by 14% per year. How much will it be worth in 5 years? When will the guitar be worth $60,000? Okay, so our equation here is exponential growth. So Y equals A parentheses 1 plus R to the X power, where A, the initial amount is 12,000, R is 14%, so that's 0.14, and then X is 5 years. All right, so now our equation is Y equals 12,000, parentheses 1 plus 0.14 raised to the 5 that's a 5, equals 23,105. So you can say that the guitar will be worth $23,105 in 5 years. All right, now that's the first part of the question. Now the next question, when will the guitar be worth $60,000? So Y will now be 60,000 equal to, we know the initial amount was 12,000 times 1 plus 0.14 raised to the x power, where x is what we don't know. Okay, so now we're going to solve this equation for x to find out how much the guitar will be worth, or when the guitar will be worth $60,000. So we're going to divide 12,000 by both sides. Well, 60,000 divided by 12,000 is 5. So 5 equals 12,000 divided by 12,000 is 1. And then times 1 plus 0.14 is 1.14 raised to the x power. Now, there's an algebraic way to solve this, but we're not going to address that at this moment. Right now, I'm going to show you how you can use a calculator to find that. So what you're going to do is go to New Document, No, now we're going to go to Add Graph, press 5, Enter, Tab 1.14 to the x power, Enter. And then you can see here that we're looking for when these intersect. So what I'm going to do is go to Menu, Window Zoom, Zoom out, click once. So basically what we're looking for is when they intersect. So I'm going to press Escape, Menu, Analyze Graph, Intersection, click, drag across, click, we found the intersection. I'm going to move the hand, control click grabs the, well, it didn't want to grab, but let me try again. So I want to, there we go. Control click grab, press escape, and you can see that x is 12.3. Okay, so the guitar will be worth $60,000 in 12.3 years. All right, so go ahead and finish up example 2. All right, now let's take a look at example 3. The value of a Ford F-150 bought new for $20,000 decreases 9.5% each year. When will the value be $5,000? Okay, so this is exponential decay. So y equals a parentheses 1 minus r to the x power. Now we need to define each of the variables. Well, a, the initial value of the car is 28,000. The rate is 9.5, which would be 0.095. We want to know why when it, or we know that, or say we want to know the year when the y value is 5,000, and x we don't know. So we have 5,000 equals 28,000, parentheses 1 minus 0.095 raised to the x power. Now you can see here that the work is going to be the same from example 2 here, so we're going to divide both sides by 28,000. Now you can see here that divides and becomes 1. You're left with 5 divided by 28 equals, that's 1, and then 1 minus 0.095 is 0.905. And that's raised to the x power. Now, at this point, we're going to solve it the same way we did in the previous example. We're going to graph. So we're going to go to New Document, No, Add Graph. Now we're going to graph 5 divided by 28, tab 0.905 to the x power, and we're looking for when they intersect. So we don't see the intersection yet, so we're going to go to Menu, and actually I can do something else. I'm going to Control click on the screen, and I'm going to pull the screen till we get the intersection, and press Escape. Now it looks like I've pulled enough to where it should show the intersection, so I'm going to go to Menu, Analyze Graph, Intersection, come over here, click, and I'm going to drag until we get the intersection. I got it just far enough, so I'm going to click, and then I'm going to come over here, Control click, press Escape. You can see that x is equal to 17.3. So I think we have just enough room right here to write our sentence. The value of the truck will be 5,000 in 17.3 years. All right, so go ahead and finish up example 3. All right, example 4. If you invested $5,000 at 5% interest compounded quarterly, how much will the investment be worth after 5 years? When will the investment be more than $100,000? Okay, so you notice example 4 is like example 1, except for instead of 1%, we're getting 5%. Okay, so y equals parentheses 1 plus r divided by n to the n x power. So now we need to define everything. Oh, almost forgot the a right here. Okay, so a, the initial investment is $5,000. R is 0.05. N, quarterly means 4. And x equals 5 because it's 5 years. Okay, so y equals 5,000, parentheses 1 plus the rate is 0.05 divided by 4, because it's quarterly, raised to the 4 times 5. And that equals $6,410.19. So I think we can use this space here for our sentence. The investment will be worth $6,410.19 in 5 years. All right. Now that's the first half of the question. Now the next question is, when will the investment be worth more than $100,000? So, and let's say not more than, let's say will be. I like more than, let's just say when will it be $100,000? So 100,000 is equal to the initial investment 5,000 times 1 plus 0.05 divided by 4 raised to the 4, in this case x, because we don't know how many years. Okay. Now we're going to divide both sides by 5,000. Okay. Which equals 100,000 divided by 5,000 is 20. So 20 equals, that's 1. 1 plus 0.05 divided by 4 is 1.0125 raised to the 4x. And again, I'm going to explain how to solve this algebraic later on in another lesson, but right now we're just going to solve for x by graphing. So we're going to go on, new document, no, add graph. So 20 and 20, enter, tab 1.0125 raised to the 4x. Now we don't see where they intersect, so I'm going to go to menu, window zoom, zoom out. Aha, I've zoomed out enough so I can see that they intersect. Press escape, menu, analyze graph, intersection, click, drag until we go over the intersection. Click, we get the intersection. Come here, grab, control click, grab the points. Press escape. So x is equal to 60.3. Okay, so the investment of $5,000 will be worth $100,000 in 60.3 years. All right, so go ahead and finish up example 4. All right, let's take a look at example 5. What is the total amount for an investment of $1,000 invested at 5% for 10 years compounded continuously? Now, when they say compounded continuously, we use the equation y equals a e to the rt, or rx. What am I doing? I guess you could use t, but technically we've already defined this as x. So rx. Okay. So first thing, we want to define what we have. Well, A, initial investment is 1,000. Okay. R equals 0.05 and X equals 10. So Y equals 1,000 e to the 0.05 times 10 equals. Now, let me show you how to put this in the calculator because I don't think we've ever used the E button. So we're going to go to on, new doc, on, not that one, on, new documents, no, add calculator. I'm going to type 1,000. Now the E button is right here. E's right there. So we press that. And then that's raised to 0.05 times 10. And so that would be $1,648.72. Okay. So the total amount after, let's just say in 10 years will be $1,648.72. Okay, so go ahead and finish up your examples and start working on your assignment and have a wonderful Wildcat day.